Hey guys, and welcome back. Today, we're going to be doing hardware pass-through, so we can do something like this. Baldur's Gate in a VM, or how about Baldur's Gate and Minecraft on the same PC at the same time? All of that stuff is possible, as well as doing things like Plex transcoding, Jellyfin, video converter, maybe in a Docker VM that also runs on the same machine that you're also gaming on, and is running Proxmox. So how do we do this? What's it all about? How do I make it work? Stay tuned, because that's what we're going to go through today. So what you're seeing here is what's known as pass-through. In the example behind me, I'm doing GPU pass-through, but I'm also doing keyboard, mouse, and Bluetooth, so that I can listen to the audio from that virtual machine, and I have input through a keyboard and mouse. That means I can play the game as though it was a regular computer, and any spare compute that's left over, I could spin up a Docker VM and I could run a number of containers out of it. So hopefully that should give you a hint as to why you might want to do this. I originally went down this route when I had my two sons and they wanted to play Minecraft. Now, I didn't want to have to go out and shell for a new PC. I have an old gaming PC, and I'll talk you through the specs of what I have here running in the background in a moment, but suffice to say, it's 6 years old, it's not expensive. I don't recommend you go and buy it, but if you could find one for dirt cheap, why not? It works. But this allowed me to give one of my sons a GPU, which I bought, just a low budget Intel GPU, and the integrated GPU as well, and I could split those up into separate machines so that they could game at the same time. So in this video, I'll give you step-by-step guides of how to do this. I'll be following the Proxmox documentation, but sometimes it's good to see somebody actually implementing that and going through the steps so that you can repeat them. And before that, I'll give you an overview of what I'm actually running this on. So looking at my machine, don't be off-put that it's in a server case. I just happen to have it in a 4U server case because I've got a rack, and it makes sense to consolidate. So in here is your bog standard ATX motherboard. It's an MSI Z170A, so that gives you a sense of its age. There's a 6700K processor in here. It's got a Noctua heatsink. It's got 32 gigs of RAM and a 750 watt power supply. And probably the most interesting thing about this is the Intel Arc A380 GPU in here. Now, I know it doesn't have rebar support, so don't berate me in the comments for that. But it was 120 quid when I bought it, and it came with a 80 quid game, which I sold and recouped the cost of, so I thought it was a pretty smart deal. Now, I've never actually tried this build with Proxmox 8, and I was quite excited by that, because Proxmox 8 released with a new kernel, which supports Intel Arcs by default. Now, I didn't know if that was going to have any impact, but as you can see, I have this up and running. So now that we've gone through my machine, how do we get this working? Well, the first thing you're going to need is a hypervisor, obviously. And as you've seen in my videos, I'm using Proxmox. Now, GPU pass-through, or pass-through in general, is not exclusive to Proxmox, and basically is a key feature of many hypervisors. I just know that Proxmox typically is more favorable, especially when it comes to consumer devices, because typically there's just a better chance it will work anyway. And Proxmox tends to be a bit more hackable, i.e. it's open source and you can tweak things to your liking, than some others, for example, that are closed source, like ESXi. Now, there's basically three major steps that we need in this process. The first is to make sure that our host has all of the virtualization setting turned on. You'll have to do that first in the BIOS, as I show on screen. And in my example here, you can see that it's VTD and virtualization. Both of those need to be enabled. Once those are enabled, you basically then need to enable IOMMU groups within Proxmox and add it to the grub file. Don't worry, I'm going to show you how to do all of this. What that's basically doing is, if you imagine your motherboard a bit like a smorgasbord, all of the individual components on that motherboard can be split up, give or take. So when you run a command, it will show you which groups each device sits in. Now, you can pass through groups to virtual machines. Now, the caveat here, and this is really important, is if two devices sit within one group and you pass that group through, both devices will go through. That seems pretty obvious, but you can often run into pitfalls where, say for example, you wanted to pass through your NVMe controller. you might have only one device in there and Proxmox is using that controller. So when you try to pass that through, it either errors or it crashes Proxmox. So you kind of get my gist. What we need to do is make sure that the devices we want to pass through are in their own IO MMU group, and that makes life a whole lot easier. If that isn't possible, there is kind of a hackable way to do that, which I'll show, and it's actually referred to in the documentation. But it's far less reliable and it's more likely to crash. And it also breaks some of the security controls that we have in place to segment devices. The next phase after that is pretty straightforward and should be much simpler to understand. We basically need to blacklist the drivers in Proxmox. So we're going to say, hey, Proxmox, don't load these drivers because we're going to steal that device from you and give it to a virtual machine. The final bit is then basically to blacklist those devices. So we find the ID of the device that we want to pass through and we blacklist that for VFIO. And we just add that simply into a configuration file and reboot the host. So those are pretty much the 3 high-level steps. So let's jump into actually doing this now in real time. So I'm going to assume that you've installed Proxmox and set that up. And whilst you're doing that, you might as well download something like Windows 11, which is going to make this much easier to diagnose. But there's no reason that you can't pass through hardware to basically any operating system. So if we wear our sunglasses and head over to the Proxmox website, you can see here all of the instructions for how to do this. But I actually think there's a few important steps that are breezed over or just assumed for the user. So keep this in mind as a reference set and come back if you need to, but I'm going to give you all of the steps that are necessary on my GitHub site, so you can just follow those. So let's go through how I did this and I'll explain all of the sort of baby steps. So now hopping over onto the server where Baldur's Gate was running, I'm going to assume that you've set up Proxmox fine. I'm going to show you how I ended up with what you're seeing here, which is that Windows 11 machine running a game. So as you can see on here, it's just my 6700K, and if you click on the Windows 11, you can see that it's got 6 of those sockets, so it's a 6 socket 8 core. That means I've basically got 1 core left, because you want to keep at least 1 reserved for Proxmox. Now, I could probably dial this in a bit, certainly if I was playing something like Minecraft, which isn't as CPU intensive. Now, the key things of note here are it's a Q35 machine. That's not the default, but when you create a Windows machine, it should default to this. But just in case it doesn't, do put it on here, because PCIe pass-through is only supported officially on Q35 machines. Also on here, when you create a Q35 and a Windows 11 machine, you're going to need to emulate the TPM, that's the Trusted Platform module, and that's typically a hardware device that's built into your motherboard, and you've probably seen this used in things like BitLocker for drive encryption. Thankfully, those are configured really simply in the Create VM wizard. Next, you're going to see some USB devices that are passed through. And in the example I showed, this was my keyboard and mouse. Now, thankfully, we don't need to do any jiggery-pokery in the command line for this. You could if you wanted, but USB devices are generally straightforward. You can do that by clicking on Add and USB device, and then you want to pass through a port that typically has the fewest issues. Here you can see that the only devices on the host are my Razer mouse and my Microsoft keyboard, which I've already passed through. The key bit to this video, and why you've probably all tuned in, is the PCIe devices that you see at the bottom. Now, you'll see 2, and I've only mentioned a GPU being passed through. That's because most GPUs are actually a GPU for the graphics and a sound card as well. So for this example, I've had to pass through both of those so that I can get graphics and sound in my VM. And probably the interesting bit here is the numbers. So these are important because these are the device IDs on our host machine. And we'll be getting onto that just a minute when we jump into the command line. So let's go and do that. So jumping into our Proxmox shell, you can do that just through the GUI, or you could run an SSH terminal. In the shell, the first thing we're going to want to do is to turn IO MMU on. Now, to do that, we simply need to edit the grub file. This is the bootloader that Proxmox uses, and it's part of Linux. There is systemd as well, so there are separate instructions for that, but the default Proxmox installation will use the grub bootloader. So to edit the bootloader, it's simply your text editor. In this case, I'm using Nano. We want to go to etc, default, and grub. And when we go into there, we can see that I've added in the default, the Linux default area, I've put Intel _IO MMU on, Now, apparently since kernel version 5.15, this isn't required. It should be on by default, but I put it in just in case because there's no downsides to specifying it. The key bit we actually need is IO MMU equals and then PT standing for pass-through. Do note that if you're running an AMD CPU, you can swap out the Intel _IO MMU to AMD _IO MMU. And that's all you need to add in here to enable IO MMU. So once you've added this, simply save and exit the file, Control-O to save, Control-X to exit. And once you've updated the grub file, you need to run the update grub command. And once you've done that, you need to reboot Proxmox, because now it will turn IO MMU groups on and it will enable pass-through. So once Proxmox has rebooted, head back into the terminal and I want you to paste this command. So this is going to validate that IO MMU is now enabled. So running that, you can see that on the third line, IO MMU is enabled. Bingo, that's great. That means that we've set up the BIOS correctly and that our devices support IO MMU. The next thing we need to do is to actually enable a few modules within Proxmox that's going to facilitate the use of device pass-through. Now, for this, we need to use VFIO, which is the kernel module that's required to enable us to pass through devices. Now, again, this is a super simple edit, copy, paste job, so let's jump into that now. So we want to nano into ETC modules, and once you're in ETC modules, you want to paste the following modules. We want VFIO, VFIO IOMOU type 1, VFO PCI, and VFO VIRQ FD. Once you've added those, again, Control-O to save, Control-X to exit. Once you've added those, again, you need to update the init ramfs and reboot. Once you've rebooted, those modules will be loaded by the kernel, and we've pretty much done all of the configuration necessary to enable us to do pass-through. So now that you're rebooted, hop back into the terminal and run the following command. This is just going to validate that the modules we specified are enabled and are working properly. So when you run this command, you're pretty much looking for that first line, the MetaDriver version, in this case 0.3. So that shows that this is loaded and it's running. So now we're going to get back to a bit that I mentioned in the Proxmox view. You know where I showed you the PCI device and it had an identification number? That's what we need to find, because when you first do this, you won't know the ID of the device that you're trying to pass through. So to do that, it's super simple. We do ls-PCI, ls being list, much like we've done for folders, -nn, and that's going to show all of the devices by name. So running that on my machine, and this will be different for all the machines that you run it on, so don't expect it to look exactly like mine. The key thing we're looking for here, as I said, are the groupings, and you can see those in the first column. Now, it's quite typical that some of the lower order groupings, i.e. things like IMOU group 1, have lots of things in that are related to the CPU and the bus, etc. And you're pretty much guaranteed to not be able to pass that through because it's going to be used by the host. But thankfully, on my motherboard, you can see that the groupings are quite favorable. So I can pass through 03, which is my GPU, 04, which is the audio device attached to the GPU, and if I wanted to, I could actually pass through my entire USB hub. So I could pass through all of the USB devices into this virtual machine. So this would actually negate, you know where I clicked on add and then a USB device? If I pass through the entire USB controller, anything I plugged into the host would automatically be given to the VM. So it would be very much like a physical machine, where anything you plug in, it becomes true plug and play. I don't recommend you do that because you probably want to be quite specific with the devices you pass through, but I don't know, maybe there's an edge case where that's useful. The other really cool thing here is, if you look at number 2, not that one, the integrated GPU, i.e. the GPU that is on your Intel chip, sorry AMD guys, you won't get that on some of the older ones, I can actually pass this through as well. So I mentioned before, I've got one GPU, the discrete one, the Intel Arc, that's going to run Baldur's Gate. And I've got one iGPU left, which, yeah, they're not great, but for things like Minecraft, it's going to be fine. Or for things like a Docker VM and transcoding, it's more than sufficient to transcode a number of 4K streams in parallel. And before anyone tries to challenge me on that, I've done 5 4K streams in parallel on an HD 530. It works. So now that we know the IDs, there's a separate command that we need to run to get the underlying vendor ID so that we can blacklist it. And as I said, this will instruct Proxmox to say, hey, I don't want to load this device, I want to leave this out. And that's the way that it leaves it available for a VM to pick it up. So how do we do that? Well, thankfully, super simple. And we take the following command, we delete one of the ends, and then we do a -s, and that was for specifying the ID we want. So in this case, I'm going to specify 0300, which, if we look on here, is my Arc A380. So hitting return on that, you can see that it comes back with a not very friendly number, 8086:56A5. That's the bit that we need to remember. So as you're going through this and it's in the shell, why don't you just copy and paste this into a notepad? And you would repeat this process for any of the devices that you want to pass through, bearing in mind they're in a separate IO-MMU group, or with the understanding that if they're not, when you try and pass through anything from that IO-MMU group, it's going to pass the whole thing through, or it might actually break things as a result. So your mileage may vary, but you should be good if it's in a separate IO-MMU group and it's not being directly used by the host machine. So in my instance, I went ahead and I did this for number 4 as well, which is the audio card. And you can see it there. It has the same first set of numbers, but a different set after the colon. And finally, I wanted to pass through my iGPU, which in this case is number 2. And the eagle-eyed among you might actually notice that it's this number here at the end of the device name anyway. So you don't have to run these separate commands if you want, but I find it quite useful to separate them out. So now that we've got those numbers, what do we do with them? Well, as I said, we want to blacklist them. So to do that, we simply take those numbers and we add them to a file. So to pass through my GPU, my discrete one, it would look something like this. So this command will echo, it will write into the file. Options, VFO, PCIe, the IDs, so those are the bits that we just found, and you would add as many as you wanted in here, each one separated by a comma. There's no spaces, just to be sure. And we also add disable VGA equals true, and it's going to be saved into the VFIO conf, which, if you remember, that's one of the kernel modules we enabled. So you wouldn't be able to do this if you hadn't enabled the kernel module. So once you've done that, hit return. That's going to write it into that file. Obviously, you could nano into that file and just manually copy and paste in there if you wanted, but this command is much simpler. So with those devices specifically specified to be isolated by the host, that's what that command does, there's one last thing that we need to do, and that's driver blacklisting. So this means that the host won't even load these drivers. So in my instance, I'm using an Intel GPU for both the integrated, because it's on an Intel CPU, and the discrete graphics card, because it's an Intel Arc. So for me, I only have to run one set of commands. It's simply the i915 driver, which is the Intel driver in Linux. So if I run this command, again, it's going to echo that command, it's going to write it into the blacklist.conf file, and you would add all of the Linux drivers here for your device. Handily, all of those are available, so AMD's and NVIDIA particularly are much more popular. So you can see on screen that it's just as simple as copying and pasting those into your blacklist.conf file. So once you've added those, naturally, you're going to need to reboot your host because it needs to boot up with those devices isolated and without those drivers loaded. Now, if you're doing this and you have your HDMI cable stuck into your machine and you're currently using the iGPU, you're going to lose it because it won't load it. So make sure that you are going through the web GUI for Proxmox, otherwise you might think that something's wrong, but don't worry. The fact that it isn't displaying an output is a good sign because it means that you've isolated the hardware, and it should, fingers crossed, be ready to be passed through to a virtual machine. So I already set up a virtual machine earlier that was running my discrete GPU, and I showed you that with Baldur's Gate. So I'll stick to my promise. I'm going to spin up another Windows machine. This time I'm going to pass through the integrated GPU. So hopefully then we'll have one VM with the discrete GPU and one VM with the iGPU, which will give us a myriad of use cases. So to create the VM, it's pretty straightforward, and if you've been following any of my videos, you should know how to do this already. So create a VM. I'm going to call this one iGPU. I'm going to hit next. I've already downloaded the Windows 11 ISO file, but again, you could use anything you want. If you're unfamiliar with Proxmox and downloading, do go check out my Proxmox installation video. It will go through all of this in much more detail. The important bit is to change the guest type, so Microsoft Windows, and this should be the bit that turns it to a Q35 machine by default. So yeah, you can see that it's created a Q35 machine. So nothing really fancy here. You can choose where you want to store the EFI and the TPM module, as I mentioned earlier. We're going to hit next. This is totally up to you in terms of how much disk size you want to give it. I'm just going to give it 32 gigs because it's just going to be to demonstrate that I've got the iGPU pass through and there's some acceleration going on. So hit next. Now, I don't have much left in the tank in this machine. I've given 6 cores to Baldur's Gate and I've only got 2 cores left, one of which I need to keep for Proxmox, just to make sure that it has enough horsepower for the overheads and running the hypervisor itself. Not sure how this is going to install with 1 core. If it fails, I'll probably bump it up to 2 and I'll edit that out of the video. But the key thing here is we get the VM up and running. It doesn't really matter what resources we give it. One thing I usually change on here is to put it as the host. This gives it all of the CPU capabilities and it makes sure that it's represented properly within the task manager. So it will show 6700K, etc. Memory, I'm just going to give it 4 gigs. That'll be fine for this. The network, I'm going to leave the same. This is just a default setup running on a bridge. But if you're integrating this into an existing setup, make sure that you choose your network adapter and perhaps it's on its own VLAN for security, etc. I'm going to confirm that, bearing in mind we haven't done any pass-through at this stage. So to do the pass-through, it's really straightforward. We click on Add. We want a PCIe device. Now, back in Proxmox 7, it would already show what is now called the raw device. So click raw device. On the drop down, we want to select the device that you want to pass through. So I've already passed through my ARC A380, so I can't pass that through. In this case, I'm going to pass through the integrated HD 530, which is on the CPU. So I will click all functions and I will click add. Now hopefully that's all that's required to boot this VM, start the installation process, and hopefully be able to see the HD 530 picked up within the device manager. So I'm going to go ahead and install this. I'll edit the installation process out and I'll see you on the other side. So now I'm on the other side of the Windows installation, and it's safe to say that you can't install Windows 11 Pro with 1 core. I end up having to use 4, but due to virtualization, that's just going to divide up the virtual cores anyway. So it should work. It's just if they're both hammering the CPU, they won't get the same performance as before. But the important thing here is that we've got the Intel HD Graphics 530 within the machine. It's recognized. There's no dreaded error 43, which has been the bane of GPU pass-through for years. Thankfully, that's not here. So, for all intents and purposes, we now have a machine that has GPU acceleration. Now, I was hoping to be able to show you some output through that HDMI port that's linked to the HD 530. But, to be honest, in some ways, there's something to gain from this failure. So, whilst I can't get an output to a monitor, I still can use the HD 530 within a virtual machine. And that really is kind of a testament to PCI pass-through. It's always been sort of experimental, and the results will vary between hardware. Now, there's a couple of things here. This is 6 or 7 generations old Intel hardware, so you may have a much better experience with newer hardware. And I exhausted all the options I could find, but there may be something existing that will fix this. I just don't know about it. So I will keep persevering. But if we just take everything on reflection, I still have a discrete GPU that's passed through to a virtual machine, and that's allowing me to game. And I still have the HD 530 available to virtual machines, so I can still use it for things like Plex and Jellyfin transcoding, and I could technically game on it if I use something like Moonlight or Parsec. So I could run the game on that virtual machine, and I could stream it to another system. So I hope this gave you a whistle-stop tour of how to do PCIe pass-through, and hopefully you'll be able to follow this process and get everything up and running. And who knows, maybe you can do the iGPU and the discrete GPU. I hope so, because that's a pretty awesome setup. Let me know how you get on in the comments below. And as always, if you like this video, please like and subscribe, and I'll see you on the next one. Take care, everybody.